is our video for finding the molar mass of compounds as well as doing the percent composition. I'm just going to combine the two into one video so that you can kill two birds with one stone. So I'm actually going to be working out the practice problems on page 228 of your book. It's the green practice problems, numbers 1 through 3. So starting with number 1, there's an A and a B. An A wants to know, okay, if you have PbCl2, what's the percentage of each element in this compound? Well, the first thing you have to do is find the molar mass. So to find the molar mass, and remember, pause this, solve it on your own, and then hit play when you're ready to see it, because I'm just going to run right through it. So to find the molar mass of this guy, you look on the periodic table. Lead has a mass of 207.2 plus 2, because we have 2 chlorine, so 2 times the mass of chlorine, which is 35.45, and you add the two of those up and you get 278.1. And of course the units on this are grams per mole. And then if you want to know the percent composition of each element, you just take the information that you have here. So this is the mass of lead. This whole thing was the mass of chlorine. And you're going to take these numbers and put them over this to find your percent composition. And of course you multiply by 100 to make it a percentage, and that looks like this. So for lead, we have 207.2 grams divided by 278.1 grams, multiplied by 100, and you end up with, incorrect sig fig, 74.51%. And then for chlorine, do pretty much the same thing. 2 times 35.45 divided by 278.1 times 100. And you end up with the remainder, 25.49%. And that is all there is to it. So B says barium nitrate, BaNO3, to barium nitrate. First thing we got to do is figure out that molar mass. So barium has a mass of 137.33, plus we have 2 nitrates, because remember this number outside distributes in, whenever you're asking how many atoms of each element, distributes into the elements that are inside. So we actually have 2 times the mass of nitrogen, which is 14.01, plus 2 times 3 is 6 times the mass of oxygen, which is 16.00. Add all that up and you get to 61.35. Now for your percent composition of each element, again, just take each of these numbers. This one's barium, this one's nitrogen, and this one is oxygen. You know what, real quick, I'm going to turn my airport off so I don't, because I'm kind of running out of battery life up here. So coming back here. Oh, let's see, we were at barium. So we got 137.33 divided by 261.35 times 100 to make it a percentage, and you get 52. Notice we get to have 5 sig figs on that one. So 52.546%. And then for nitrogen, we have our 2 times 14.01 divided by that same 261.35 times 100. And that is equal to 10.72%. Then for our oxygens, we take 6 times 16 divided by the 261.35 times 100, and you get 37.73%. And don't forget, if you want to double check yourself, just add all these guys up and make sure that it adds up to something that is really close to 100, and you know you're right. All right, number 2 says find the mass percentage of water in zinc sulfate heptahydrate. So finding the percentage of each thing, actually no, finding just the percentage of water. So take and find the mass of this whole compound. So zinc has a mass of 65.39. Add to that the mass of sulfur, which is 32.07, plus 4 right here times the mass of oxygen, plus 7 times the mass of water. And the mass of water is 18.02. I'm not going to make you memorize this number, but you're probably going to end up memorizing it anyways because that's just how this goes. So this whole thing adds up to be 287.60. So to figure out the mass percent of water, this part right here was the only part that dealt with our water. So we take 7 times 18.02 for our waters, divide it by 287.60, and you end up with 43.86% water. Last one we're going to do is number 3. It looks a little bit different and might kind of throw you off a little bit because they already give you the percentage of oxygen as 54.87% oxygen in the compound magnesium hydroxide, which is MgOH2, but you don't really need to know that. And so they want to know if you have 175 grams of magnesium hydroxide, how many moles of oxygen do you have? So, if we have 175 grams of magnesium hydroxide, and 54.87% of that is oxygen. In order to get all the way to moles, we first need to figure out how much oxygen we have. So if you take this 175 grams and multiply it by 54.87%, or just take 175 times 0.5487, because this is how you mathematically work with percentages, then you end up with 96.0 grams of oxygen. And then it just becomes a simple stoichiometry. We say, okay, we have this many grams of oxygen, how many moles of that? Well, 1 mole of oxygen has a mass of 16 grams. So set this up. Since we got grams on top, we want grams on bottom down in here. So this 16 grams goes on bottom. Our 1 mole goes on top. Grams cancel out, and we end up with 96 divided by 16, which is 6.00 moles of oxygen. Now, if you have any more questions, still confused about how to figure these out, then just come on in for tutoring. And if I need to post up more example problems, I can do that too. Just ask me in class. So I'll see you guys tomorrow, and don't forget your bubble gum.